Good evening to everybody. Today we are going to discuss ion-electron method, or it is also called as a half reaction method. In this case, in redox reactions, we have taken an example of oxidation of manganese as well as reduction of chlorine. This sample reaction we have taken for consideration. Now we have to follow 5 steps to balance this reaction. Now in step first, what we did, we have assigned the oxidation number to the each element. Means, for example, in this given redox reaction, there are many elements. To that each and every element we have to assign the oxidation number. For example, here Mn is in ionic state, so manganese, I have assigned oxidation number to this manganese is +2. Like that, for chlorine I have assigned +5. Oxygen, I have assigned the oxidation number to oxygen -2. Like that, manganese is +4 in oxidation state here, and chlorine is +4. So we have to determine the oxidation state of each and every element in step first. Now, in step first only, what we have to do, the oxidation half reaction you have to write. Now, in this case, both half reactions are present. Means, oxidation half reaction is present and reduction half reaction is present. Oxidation half reaction in the sense, I have denoted with the help of these arrows. The manganese which is present at the reactant side in +2 oxidation state, it converted into +4 oxidation state. It indicates that there is a oxidation takes place. So this half reaction I have written here, that is Mn2 plus is converted into Mn42. Now we have to write the reduction half reaction again for ClO3, that is chlorine at the reactant side, it is present in +5 oxidation state, and I have shown with the help of arrow here, it will convert it into +4 oxidation state. This indicates that there is a reduction takes place, means one electron is added and chlorine is converted into +4 oxidation state. I have mentioned here reduction half reaction, that is ClO3 minus is converted into ClO2. Okay, now we will move to the next step, that is step 2. In step 2, what we have to do, we have to balance the oxygen atoms. So Mn2 plus, when it is converted into Mn42, here at the product side 2 oxygen atoms are there. So to balance this oxygen, I have to add 2 H2O at the right hand side of the equation. So I have added 2 H2O to the left hand side of the oxidation. Now in the another half reaction, what we have to do, we have to count the number of oxygen atoms. At the reactant side there are 3 oxygen atoms are there, and at product side only 2 oxygen atoms are there. So to balance this oxygen atoms, we have to add 1 H2O at the product side. So I have added 1 H2O at the product side, that is right hand side of the half reaction. Now we will move to the next step, that is next step in the sense step 3, balance the H atoms by adding H plus ions. In this case, both the half reactions are present, means H plus ions we have to balance at the both the sides. Here in Mn2 plus, that is oxidation, I have added 2 H2 atoms, but the number of H plus ions are not balanced. So to complete means to balance the H plus ions, I have to add 4 H plus ions at the product side. Why? Because for balancing oxygen atoms, I have added H2O, but number of H plus ions are not equal. So that's why I have added 4 H plus ions at the product side. So in reduction also, what I did, I have balanced oxygen atoms in previous reaction, but hydrogen atoms are not balanced. So to balance that hydrogen atoms, I have to add 2H plus ions at the reactant side, that is left hand side of the half reaction. So this is the step 3, that is balancing of H plus atoms. In step 4, what we did? In step 4, we have balanced the number of electrons. This is the important step. So in oxidation, what I did? In oxidation, number of electrons are not equal. The manganese which is present at reactant side having 2 electrons, but at the product side, if we determine the oxidation state of Mn in MnO2, we will get plus 4. So to balance the number of electrons, what I did, I have added 2 electrons. In the same case, in reduction process, I have to add 1 electron to balance the oxidation state of chlorine. Now look at here, at the reactant side, the chlorine has oxidation state plus 5, but here the oxidation state of chlorine is plus 4. So to balance the number of electrons, I have to add 1 electron at the reactant side. Now in step 4, what I did, I balanced the number of electrons. Further, we will move to the next step, that is step number 5. Here in this case, we have to add both these equations, because what we did, first we have assigned the oxidation number to the each and every element. From that, what we have got, we have means in the given reaction the number of oxygen atoms are not balanced. We have balanced the number of oxygen atoms, and after that we have balanced the H plus ions, and after that we have balanced the number of electrons. So up till now we have written both these equations, but we have to write the net reactions. Net reactions in the sense all the things are balanced now. So we are going to the conclusion, that is net reactions we have to write. In that case, what we have to do, we have to assign the number to the both equations. I have given half reaction, first half reaction and second half reactions, means I have assigned the numbers to the both the equations. Here both the reactions I have added, but in this case the number of electrons are not balanced still. In first equation the number of electrons are 2, and here the number of electrons are 1. But according to the given equation, the number of electrons we have balanced, but when we want to write the net reaction, at that time both half reactions should have the equal number of electrons. So for that purpose, what we did, we have to balance the number of electrons of both these equations. Here the number of electrons are 2, and here the number of electrons are 1. So what we have to do here, we have to multiply the equation 2, that is this second equation, by 2. That the same thing I have did in step 5. What I did, I have multiplied this throughout equation by 2. So the number of electrons are balanced now. Look at here, the number of electrons in first reaction at the product side are 2 electrons. After multiplying, the number of electrons become 2 at the left hand side of the equation. So in both these equations now electrons are balanced. So which terms are going to be cancelled? I will notice here. At both the sides 2 H2 are present. First of all, I have cancelled the H2 atom, H2 molecules. Then we will go to the H plus ions. 4H plus ions, 4H plus ions get cancelled. We will go to the next, that is 2 electrons. At both the sides 2 electrons are present. I have cancelled it. So what will remain, that we have to write in final equation. That is, we will get Mn2 plus 2ClO3 minus and MnO2 plus 2ClO2. These things are remained at the last of the equation. So this is the method how we can determine or we can say how we can balance the given redox reaction with the help of, or this is also called as a half reaction method, or we can also say ion-electron method. So this is the simplest method by which we can balance the given redox reactions. Thank you very much.